Today let us look at completion of squares. Let us look at this quadratic equation x square plus 4x minus 5 is equal to 0. We have already seen how to factorize a quadratic equation by splitting the middle term. We look at the coefficient of x square and the constant term. The product of these gives us minus 5. Now we have to find two factors of minus 5 that give a sum plus 4. So we could write 5 minus 1. Splitting the middle term, we get x square plus 5x minus x minus 5 is equal to 0. Now let us take the first two terms together and the last two terms together and see if we can take anything common. Taking the bracket x plus 5 as common, we get the other bracket as x minus 1. Now since the product of these two factors is 0, at least one of them has to be 0. So putting x minus 1 equals 0 or x plus 5 equals 0, we get x is either 1 or x is minus 5. Now this method was splitting of middle term. Let us see if there is another way to solve a quadratic equation. Let us write x square plus 4x minus 5 equals 0 once again. Now let us look at the first two terms with the variable x and compare it with the identity a square plus 2ab plus b square. If a was x, then we could write 4x as 2 times 2x. Now this means that b would be equal to 2. So let us add and subtract the term b square. Here it would be 2 square. So let us add and subtract 2 square. Now we could write the identity as a plus b whole square. So the quadratic equation becomes x plus 2 whole square minus 2 square minus 5 is equal to 0. Now let us simplify the rest of the terms and take them to the right hand side. So we get x plus 2 whole square is equal to 9. Now the square of which integer is equal to 9? There are two possibilities, plus 3 or minus 3. Taking square root on both the sides, we get two linear equations, x plus 2 equals 3 or x plus 2 equals minus 3. Upon solving, we get x equals 1 or x equals minus 5. These solutions are the same as we obtained before from splitting of the middle term. Now this method, where we have used the identity a plus b whole square, this method is known as completion of square. Let us see how this looks geometrically. So we have a square with side x units. And we have a rectangle with sides 4 units and x units. Now the area of the square is x square and the area of the rectangle is 4x. Now let us break the rectangle into two equal parts with sides 2 units and x units. Now let us rearrange these rectangles and we see that we are short of one small square to complete the big square. Now the small square has side equal to 2 units. Recall that we added 2 square. Now this new square has the side x plus 2 units. So the area of the bigger square is x plus 2 whole square. So we have completed the square. If we were to solve for the square, then x plus 2 whole square equals 9. We would get x plus 2 equals 3 because length cannot be negative. So geometrically, we get only one solution, whereas algebraically we get two solutions. Let us look at a few problems. Find the roots of the quadratic equation x square plus 6x plus 3 is equal to 0 by the method of completing the square. So let us write the quadratic equation and compare the first two terms with a square plus 2ab. We see that if a was x, then b would be equal to 3. Now let us add and subtract b square. So we are going to add and subtract 3 square. Now let us use the identity a plus b whole square. Now let us simplify the rest of the terms and take them to the right hand side. So we get x plus 3 whole square is equal to 6. Taking square root on both the sides, we get x plus 3 is equal to square root of 6 or x plus 3 is equal to minus square root of 6. Solving these two linear equations, we get minus 3 plus square root of 6 and minus 3 minus square root of 6 as roots of the given quadratic equation. Let us look at another problem. Find the roots of the quadratic equation 2x square minus 7x plus 3 is equal to 0 by the method of completing the square. Now let us look at the first term, 2x square. But if a was square root of 2x, then the next term minus 2ab would fetch us a value of b where we would have square root of 2 in the denominator. That sounds complicated. Let us try another way. Let us divide the quadratic equation by 2, or let us take 2 common. Now our quadratic equation looks simpler. Let us compare this with a square minus 2ab now. Now if a was x, then we would get b as 7 divided by 2 times 2, or 7 by 4. So let us add and subtract 7 by 4 whole square. Now we could reduce the first three terms as a minus b whole square. Let us simplify the rest of the terms and take them to the right hand side. Let us take LCM. And we get x minus 7 by 4 whole square is equal to 25 by 16. Let us take square root on both the sides and simplify. We get x is equal to 3 or x is equal to 1 by 2. We could also check these results by substituting these values of x in the quadratic equation and checking if the quadratic equation is satisfied. Let us look at another problem. Find the roots of x minus 1 by x is equal to 3, where x is non-zero. Now let us get rid of the x in the denominator. So let us multiply the equation with x. And we get a quadratic equation. So let us take all the terms to the left hand side. We see that the middle term has a negative sign. So we shall compare it with a square minus 2ab plus b square. Now if a was x, then b would be 3 divided by 2. Let us add and subtract b square, which is 3 by 2 whole square. And now we get a minus b whole square, or x minus 3 by 2 whole square. Let us simplify the rest of the terms and take them to the right hand side. Let us take square root on both the sides and simplify. We get 3 plus square root of 13 by 2 and 3 minus square root of 13 by 2 as roots of x minus 1 by x equals 3.